Good day, folks. Today's update here on the project. A few things on the go here. Let's see now. Not much on this side from basically yesterday. Oh, I added some more high voltage terminal strips here, which I screwed right into my plywood here. So it's going to be nice and solid. Same thing here. So this is my high frequency neon transformer. So just to experiment without like zapping myself out of this room here, this is only like 3 milliamps, 3000 volts, but it's high frequency, so good enough to observe some of the effects for experimentation. So over here, my full bridge rectifier, which is also a voltage multiplier. So you get DC output pulse out of this here. And yeah, this is the inverter, very low, just enough to drive this here. And the terminals worked on the screwing it, because I want everything to be solid so I could like move this around, right? Even pack it if I had to down the road. So over here, yeah, I'm still working on all of this eventually, because I've got these, I don't know if you can see it over here, right at the end there. These are all very high voltage cables that I can cut specifically for neon transformers, and I could use that for my connections here. So the output of this is going to feed primary coil here, but I don't want to closed loop it with a spark gap, so instead we're going to closed loop it with the fluorescent lamps here, which doesn't use very much power, by the way, so it's almost like having it like a one wire. But anyways, it's work in progress, and many of the concepts which I've talked about in the past, which I'm just putting on steroids here basically. So this would be a form of coupling coil here. What's very interesting, I don't know if you can see that, but in here there's another coil, so you can literally mess around with the phase, the resonance, and this is going to be the pickup, which I don't have yet. It's going to charge the high voltage capacitors, and this will output DC, but there's all going to be all that high frequency component to it. It's going to go into this RF choke here, and this is already half assembled here. It's in there. So let's see here, RF choke here is going to be quote-unquote DC, but there's going to be a lot of noise to it. So all the fluctuations on the DC side are going to trigger, basically the noise is going to come out here as a radiant field instead of into the load, right? So the secondary one could be used for feedback like Don Smith was doing, and its own rectifier, and could charge the input battery. So a lot to consider here. And this here for additional tuning is a set, because this creates a very strong radiant field, which is normally wasted. Don Smith figured that out, right? But I'm pretty sure there's a lot more in there, and with the fluorescent tubes, it can have an interesting interaction with plasma-like effects. This here, variable capacitor for tuning, essentially tuning into like the peaks like a radio signal here. And these capacitive plates over here, they can handle a couple thousand volts, you know. It was very difficult finding a variable capacitor that's basically over 1000 volts that's not vacuum based. So I'm going to experiment with those, but not right now. So yeah, a lot in the works here, and it's going to allow me to experiment with a few concepts that I always wanted to validate. And while we're doing that, I'm experimenting with a bunch of other stuff over here. More kind of like high pass, low pass RF kind of choking, variable tuning, which I was messing around with the plasma tube here, the Russian noise generator tube, which is over there that I just showed you. So more RF chokes here, different inductance values. But I want to show you folks something very interesting here. This is something Don Smith had in like his suitcase device right there in the corner that hardly no one ever talked much about, which is a key element, because not only does it filter out that bad HF signal from your load, it takes something bad and makes it good. you can couple into this secondary coil on its own, rectify that wasted field and actually use it, and then still run your load. I'm going to actually show you. I actually ran this and it works. It was very loose on here and not well done, but I'm going to redo it all on the plywood and eventually show a demo of this, which essentially you're decoupling the electric and the magnetic components and treating them separately. And while the load runs fine here in my lamp, it doesn't detect at all that you're charging a battery through the secondary here. So it's like a transformer, but without the typical transformer coupling you normally get, because this is an air core. You don't have inductive. It's not this typical transformer type linear action, and it's usually a filter for RF, but we're just being clever with it. You can use it as feedback. Something else, pay very close attention to how all of these RF chokes are. They all have a vinyl around the core. So in other words, something else Don Smith never talks about. At high frequency, these become capacitors. Yeah, I know, right? And pay close attention to the winding style here. See, they partially overlap each other. Not a flat out, 90 degree, but, pretty close. So, just something else, and they're all like that, by the way. If it's an RF choke, and this is not the typical transformer winding. See, same thing here. It's much smaller choke, right? But it's still an RF choke for higher frequencies. But same style, vinyl coating. And you see the windings, right? It's not the typical. Just give you more perspective on this, because again, the things that Don Smith never zooms into, and not much people pay attention, but it's a big component of a lot of this stuff. It's literally choking the RF and doing something good with it. Instead of wasting it just as a radiating field, okay, we get it, right? It's not going into our load where we don't want it, so it's radiating, it's becoming a radiant energy. So instead of wasting it as a radiant field, just hovering around the core here, couple into it as a secondary through pure resonance, and then you got yourself another, what we would call an energy sink while you run your load, right? So now it's just a matter of varying, experimenting, and connecting all of this. And, something else that's very interesting, which good to have, basically just another step-up transformer at 60 hertz. What I like about this one is usually they're all covered, so you don't get to see inside of them. So now you easy access to the core, as you can see. And these here are for high frequency, because I want to eventually experiment with higher frequencies here. So this is a Tesla coil I was talking about, conical, so much wider band, much more frequency range. And it keeps basically the same idea. And what I want to do eventually is like shove a spark gap in there. I've got these tubes here. I think you remember these, right? Kind of like what Don Smith was doing. And use that to capture the radiant. And yeah, I'm still all in the works. And oh yeah, we're going to get into some Bedini stuff here a little bit, back to the basics. Don't have the gears and the belts for this yet, but that's something else in the work. Pretty heavy flywheel, actually. Got to put some magnets. Find a good glue or something. I don't know what glue I could use, but I'm going to put magnets around this. I'm going to show you. I actually have the coils. If you want to bear with me here. Hold on, I'll show you the coils. Okay, so these are the coils I want to use. I don't have the mount for them, but essentially, you got this there. Got the magnets all on here. Flywheel runs. And I'm going to have something here that holds these things here. Right around there. And as this spins, may as well get some power out of there. And pulsar motor 50/50. It's pretty easy with an Arduino switch these days. So just back to the basic, a side project, you know. As you see, I'm working on a lot of things at once, just trying to tackle everything I can. And something I worked on today, another kind of Don Smith coil. So I'm proud of this one. There's a primary and secondary. So the primary is the drive, which is the coil inside. And what I had to do is I put some vinyl, which is basically nail polish. You can see some of it there, all around the primary side, just to keep everything more rigid and stable. And there's more reasons about having the vinyl coating on the primary, which I'll get into on more in detail in some later time. But there was a method to the madness. So the tube goes in there, and on the outside tube you got your secondary, which is 2 times, you know, the primary. And I've got all my wires here to connect to. So still a work in the process. So I'll have that one as well to validate and confirm some more ideas and effects that I want to look into in greater details. So basically that's what I've been doing. This one here kept me busy much of the day trying to get it. I don't want to break anything, right? So I'm like it, very well insulated. I like this. Plastic screws, well mounted on the board. So, you know, bit of space. So we're getting there, folks. Again, my apologies for not actually, you know, well, eventually I'll have things more like what you would consider operational, but just keeping everyone posted and up to date. And until next time, and thanks for watching.